All right, so I wanted to do the part two for section 4.3. And so this is basically the same concepts as what the part one was, except now instead of looking at graphs and getting all the information from the graph without the equation, we're going to look at the equation and see that we don't need the graph. So I thought we'd do a little algebra review first because the quicker you can see things from linear graphs and quadratic graphs, easier this will be, I think. So if we look at, let's just look at a couple of linear functions, and we don't need to know everything. It's not that we need to get detailed graphs of these, but if we look at a linear function, y equals 4x plus 7, we know that the slope is positive. Y-intercept, we're not really that worried about, but we will be worried about the x-intercept. So setting that equal to 0, solving for x, we get x is negative 7/4. So we'll just put that somewhere there, positive slope. And so the graph looks like that. And so what we're interested in for this section, for the purpose of what we're doing, is that the function is negative from negative infinity to negative 7/4, and then positive from negative 7/4 to infinity. And that's really all we're worried about. We don't really care about the y-intercept at all. Then the other one, we have y equals negative 2x plus 3. So of course that one is negative slope. And let's find the x-intercept. Solve that for x, and we get 3/2. No, that's not right. We yeah, that is right. We get 3/2. So positive 3/2 will be over here. It's a negative slope, so we'll just draw it like this. And so likewise, we can see that the graph is positive on this part, so negative infinity to 3/2, and then negative from 3/2 to infinity. And so that's going to come in handy. And so the point of that is this will save us a little bit of time if we can do that. And it's really helpful with the quadratics. So let's do a couple of quadratic graphs. And you've definitely learned this in algebra, but perhaps you forgot. Either way, this will be a good review. So the first thing we'll be doing is finding the zeros. So we can factor that, x minus 2, x plus 2, or x plus 1. So we get x equals 2, x equals negative 1. And so if we look at the zeros, so we have 1 at negative 2, and then we'll have 1 at, or sorry, negative 1, positive 2. And then the other thing that you want to make sure that you remember is when this coefficient with the x squared is positive, that tells us that the graph opens up. So in other words, the graph will look like this. Now, for our purposes, we're not really concerned about how far down this goes. We're not looking at the range. We don't care about the range. All we care about is where it's positive, where it's negative. So in this case, this graph would be positive from negative infinity to negative 1, and then positive from 2 to infinity, and then it's negative between those two. And that's what we're concerned about. So the quicker you can see that, given the zeros, given the leading coefficient, we can figure that out pretty quickly. And then likewise with this one, and I want to factor out a negative first. Then we factor it, we get x plus 3x minus 2. So x is negative 3, x is positive 2. Plot the zeros. So we have a 0 at negative 3, we have a 0 at 2. Now this one, factor out a negative here. So looking at the original, the leading coefficient is negative, so this one's going to open down. So leading coefficient opens up, leading coefficient positive opens up, leading coefficient negative opens down. So this one will look something like that. And again, we're not worried about how far up we go, how steep it is, anything like that. all we're worried about is where is it positive, where is it negative. So this one will be negative from negative infinity to negative 3, and then from 2 to infinity, and then it's positive between negative 3 and 2. So if you can do that, that will save you a little bit of time when you're doing our problems in this section. So let's look at a little bit of review from what was on the last video. I won't go through this as in detail. It's on the part 1. So if the derivative is positive, f is increasing, negative, f is decreasing. And then we have the first derivative test. We're actually going to use the concavity test on this one. Second derivative is positive, means the graph of f is concave up. And then if it's negative, the graph of f is concave down. So we're going to use that. We're going to find where it's increasing, decreasing, max and the min. We're going to find where it's concave up, concave down, and then we're going to find the inflection points. So let's look at this first one. And so if we take the first derivative, we just have 6x minus 11, set it equal to 0, and x is 11 over 6. All right, so we need to figure out where is the derivative positive, where is it negative. So that is our critical number, 11/6. And this is a positive slope linear function. So it's going to look like that. And so it's negative over here, positive over here. And of course you can do test points. And you do need to get proficient at doing that, because sometimes you won't be able to just think about the graph. But big point over here, something less than 11/6. So 0 is obvious, easy choice. Plug in 0. We just end up with y prime is negative 11. So that's obviously negative. Pick another number greater than 11/6. So if you pick 10, 6 times 10 minus 11 is going to be positive. So you can do it that way also. But once we get to a little bit more complicated, like cubics or quadratics, then it's easier if you think about the graph. But either way, so we're increasing where the first derivative is positive. So that is 11/6 up to infinity. We are decreasing where it is negative. So that would be negative infinity to 11/6. And then if we want to find the min or the max, so it's easiest if you think negative is decreasing, so we're like that. Positive is increasing, so we're like that. So if the graph comes like that, then this is going to be a minimum. And then it's quadratic, so it either has a minimum or a max, but not both. So the minimum, we're going to plug in 11/6 into the original equation. And I'll let you do that on your own if you want, but the minimum will be negative 73 over 12. So plug in 11/6. And if I did my math right, then you get negative 73 over 12. And actually, that's not an ordered pair. So we can just write negative 73 over 12. So for the minimum, you just write the minimum value, the y value, and then the max does not exist because this is a quadratic and you either have one or the other. All right, and then if we want to do the second derivative test for the concavity, actually, that's not the second derivative test, that's something else. But test for concavity, find the second derivative. It's just 6, and so that is, so y prime is greater than 0 for all x, and so it's concave up for the entire domain, negative infinity to infinity. And then inflection point, so inflection point, if you remember, is where the second derivative changes signs, or where it goes from concave down to concave up, vice versa. And since it's always concave up, there is no inflection point. So that was kind of a simpler example with quadratic. We don't have as much going on as with a cubic or a higher degree polynomial, but you get the basic idea. It takes first derivative to find where it's increasing, decreasing. You can find the max and the min, and then second derivative to find the concavity and inflection points. All right, so if we look at number 4, example 4. So this is a cubic. So let's find the derivative, and we're going to do the same thing for all of these. Increasing, decreasing, max min, concavity, inflection point. It's pretty much all you do. This homework is pretty repetitive in that way. So take the derivative, 3x squared minus 12, set it equal to 0. And I'm not going to do all the algebra, but move the 12 over, divide by 3, you get x, take the square root, x is plus or minus 2. All right, so now, again, you can plug in points in these intervals. So plug in -4, plug in 0, plug in 4, or whatever number you choose. But this is a quadratic positive leading coefficient. So it is going to look something like that. So we have our quadratic. Of course, it goes through these zeros, but you can see it's going to be positive, and then it dips down between those two, and then positive again. So that means we are increasing from negative infinity to -2, and then from 2 to infinity, and then we're decreasing between those two. All right, and then we find the max or the min. So we're increasing, decreasing, increasing again. So I have a maximum there and then a minimum there. So for the max, we're going to find f of -2 and plug that in. We should get 17. And then the minimum, we're going to find f of 2, and we should get -15. And of course, one of the things you want to make sure when you're taking a test is make sure that your maximum is actually more than your minimum. If you do something wrong and you get a minimum is -15 and the maximum is -30, then clearly you should recognize that as a mistake. So don't get in a hurry and make little mistakes that mess you up like that. All right, so now we're going to do the second derivative. Second derivative is just going to be 6x. Set that equal to 0. Obviously, x is going to be 0. So now put that on the number line. And you can test points or look at the graph. Test the negative number, plug in a negative number, f of -1. We obviously get a negative. F of 1, obviously get a positive. So we are going to be concave down, concave up. So concave up from 0 to infinity, concave down from -infinity to 0. And then the inflection point, and it is a point, so you're going to put an ordered pair. Plug in 0 into the, so obviously it changes at 0. So we're going to plug 0 into the original function. And of course, we get 1 when we do that. So the inflection point is 0, 1. All right, I think one more, and that will be good for the polynomials. So another cubic, and so let's take the derivative. We're going to do the same thing that we've been doing. So we have 12x squared minus 6x minus 18. Set it equal to 0, and we can factor out a 6. So we have 2x squared minus x minus 3. We can divide by 6. It's not going to change anything. And then factor this. So we have 2x and minus 3 and x plus 1. So both equal to 0. We get x is 3/2 and x is -1. Put those on the number line. Just make sure you put them in the correct order. And again, this is a quadratic positive coefficient. So it's going to have our -1 there, 3/2 there, and then it's going to look like that. So we're positive, negative, positive. And so that means we are increasing from negative infinity to negative 1, and then from 3/2 to infinity. And we're decreasing between those. So -1 to 3/2. All right, and then if it helps, draw the arrows. So increasing, decreasing, increasing. So maximum, minimum. So maximum, we're going to plug in -1. So f of -1 it would come out to 15. And then the minimum, plug in 3/2. And that should come to -65/4. All right, and then so increasing, decreasing, max, min. Now we'll find our second derivative, figure out the concavity. So we get 24x minus 6, set it equal to 0. 24. And of course, x is 1/4. All right, so 1/4. Put that on the number line. If we plug in a number less than 1/4, we can plug in 0. F double prime will be negative. Plug in a bigger number like 1, F double prime will be positive. So we have concave down, concave up. And then, so then we can write in interval notation. So concave down from negative infinity to 1/4, concave up from 1/4 to infinity. And then the inflection point changes signs. So 1/4 is indeed an inflection point. We're going to plug in 1/4 into the original function. And the inflection point is a point. So it's an ordered pair, 1/4, and you should get -5/8. Like that. All right. So hopefully you see how repetitive this is, as long as, especially working with polynomials. And we don't get into high degree polynomials, so it's not too bad with the algebra part of it. But make sure you're proficient at taking the derivative. Make sure, obviously, if you're in this class, you should be good at factoring and solving quadratic equations and linear equations. But as far as that goes, just the more you practice it, the better you will get. So, and I know it went kind of fast, but it is repetitive. You can pause the video if you need to go back and re-listen. But I would encourage you to write down what I'm writing down as we do it. So pause it, write down what we're doing, make sure you understand. And if you have any questions, you can, of course, let me know. All right, I'm going to do another one with non-polynomial functions. So